when you're building a machine learning application from scratch, there's a couple things that are interesting that come into play. And one of them is, how do you get a model and save it somewhere and do something with it? You'll see if you go to Kaggle, for example, there's no shortage of people with notebooks and doing things on COVID-19 and all kinds of stuff. But what you don't see is, okay, great, you built this notebook that predicts COVID-19 cases or whatever it does. So now how do I use that notebook? And there's really a shortage of information on this. And that's a lot of what we're going to cover today is how would you get something like a Kaggle project or some other data science project and actually do something with it so that your company can use it and deploy it. So that's really what the spirit is of this project here. And I'll put this into our little chat area here. So this container microservices uh, project, what it's going to do is going to set up and configure Docker locally, set up and configure Kubernetes locally, create a Flask scikit-learning app, also figure out how to control a cluster and deploy it, load test it, verify, auto scale. But before we do any of that, one of the things to look at is this notebook, which is this Boston Housing dataset pickled model in Colab. And this is really a copy of something from Kaggle. I didn't even write the code myself. I just kind of tweaked somebody's Kaggle project and added some things to it so that it made it easier to dump it out. And this is actually not a bad way to play around with getting machine learning running. Is just go to Kaggle, find some project, copy it. So basically, at the very beginning here, you'll see that this is just some person on Kaggle. I don't even know who, they probably copied another person that copied another person. So I just took their code and just tweaked it a little bit. And at the very beginning, there's a data frame that has all the data. I do some exploratory data analysis, which is typically what people do, drop some data, and then I get into the modeling phase. And the modeling phase, all I do is I get the X train, X validation, Y train, Y validation, and I pull it out. So with machine learning, typically what happens is you have training data, so you kind of trained it on historical data, and then you test it on data that wasn't part of the training so that you can verify whether it worked or not. So a good example of this would be, we see this all the time. There's pundits on TV and they'll say something, right? And we see this in the coronavirus all the time, this is very serious or this is not serious, or they'll say some number, right? That's basically like that's their prediction, and then reality happens, and then and then you can test how accurate their prediction was against reality. It's kind of the same concept here. Is like you train it and you come up with a prediction, and then you go and you validate it against reality, and then either it was good or it was a bad prediction. So next here, um, this is where all the scaling takes place. Most machine learning models, you have to transform the data so that the dimensions are the same. So, if you have one that's in miles and another one in inches, you standardize it. And so I guess I could just run all this real quick just so you can see it, just so we can verify that it in fact works. So first, here's the imports. Here's the EDA. Okay, this is scaling it. It does a grid search right here. And this grid search will figure out the parameters basically. So what's the best model to pick? And then finally, we fit the model. So again, I go through here, I scale the data. I use this model called gradient boosting. It doesn't have to be gradient boosting. It could be linear regression, or it could be whatever, some model. I fit it, and then that's it. That's the process of machine learning. So for somebody that's deploying the machine learning, up until this point, maybe you don't even care about it. You just trust that someone you're working with did a good job and they give you the model. Now let's get into the part where, okay, I got the model. How do I actually get it into production? So here's some of the things that I typically would do is I would first just double check that it works. So, make sure that, okay, great. Here's what I predicted. Here's what actually happened. So again, no one will die from coronavirus, and then people die. Okay, well, I was off by a little bit. Um, and then I go through here and I say evaluate, describe. I then go through and I'll play around a little bit with it just to kind of get a feel for, okay, if I was going to build an API using this model, what would it look like? How would I do things? And what I'll do is I'll actually add a JSON workflow inside of it. So you can see here, I actually take the data frame here and I make it into like a JSON data structure. So I can see, okay, this is, if I was going to accept something into an API, this is what I would need to put inside. But because machine learning models need the data to be scaled, I would also need to scale it. So you can see here, this is what I would do is I would take that JSON payload, put it into the scaler, then I would transform it and do my prediction that way. And you can see here we go. Here's my prediction. So basically I kind of put the pieces together that later will go into my API, but I do it in a place that's really easy to debug. Finally, now that I know it works, the last part is I save the data, save the model to disk. And the way you do that in scikit-learn is you say from scikit-learn.externals import joblib. I then do joblib.dump, and then it puts the data out to a file. And then when I do an ls here, you can see that that joblib file is now on disk. So what do I do next? Is then I would basically then test, okay, I saved it out to disk. I could transport my model back and forth. Okay, how do I actually do stuff with it? Well, first load it back in. I assign it to a variable called CLF, and then I then test it again. Okay, here's my prediction. Okay, great. Here's my sample. Here I scale it again, and I kind of walk through. So the only reason that I do all this is just to test all the things that would happen later in a Flask app, and also to save the model. And if I wanted to grab it out of here, so if you wanted to completely copy what I'm doing, I could click here and I could see, look, there's the model that I just created, and I could actually just right click on it and just click download. And then now I can bring it to some other machine. I could run it on my laptop, I could run it in the cloud, I could run it anywhere. So next up, now that we know that works, here's really the steps that are involved is, make a project that has a Docker file, build and test it, push it to Docker Hub, pull it into the cloud, predict, maybe extend it by going into a container, maybe pull it into ECR. There's a whole bunch of stuff that we could do here. There's actually a really crappy diagram. But so what I'm going to do is I'm going to basically take it to the next level and bring this into Cloud9. So we're familiar with Cloud9. So let's actually just start working on this in Cloud9. So I'm going to go to AWS here, go to console, log in, and put in this auth code. Let's see here. And let's see here. And now if I go to this, I can type in Cloud9. And what I might do is, to be lazy here, is just pick something that already is kind of set up, like Docker build. I probably was doing something with that at some point. Maybe even have this project on there just to speed things up a little bit. Okay, let's wait for this thing to wake up. And while that's waking up, I'm going to clone this. So I'm going to go over here and put copy, clone this thing. Okay, so what I'm going to do now is just kind of delete stuff on this environment, because there's a bunch of stuff here that just I want to get rid of. So rm-rf star. Typically, this is naughty to do because it's very destructive, but in this case it works because I wanted to delete everything. Okay, close tab. Okay, so now what I'm going to do is I'm going to clone this, git clone, pull out the microservices. And now you can see this general structure inside of the demos section here. There, this is really the heart and soul of what everything's going to do. And let me just walk you through some of the stuff. So I have the file, right, that I downloaded earlier. I checked it into GitHub. And the part that's really the interesting parts would be the Docker file. Let's go take a look at this real quick. So what this Docker file does is it uses the Python 3.7 base image. It makes an app directory. It copies the app file into this location. It does a pip install. It exposes port 80, and then it runs it. So basically it containerizes this application so I could run it at scale in maybe Kubernetes or something like that. So let's first just get this thing running outside of Docker. So to do that, we'll do what I typically do is create a virtual environment. So I'll just make one real quick. So I'll say Python 3 virtual environment and say tilde dot container revolution. That's long enough. I'll source it. Container revolution, then activate. There we go. Now I'm in this virtual environment, and now I can cd into this project and go into the demos directory, go into Flask scikit-learn. Okay, so now that I got this, what I would typically do is look at the makefile, because I always create makefiles in my project, and you'll see inside this makefile, because I follow my own rules, I have an install, right, which will install the packages, and then also in the requirements file, I actually even pin the package number so that I know that the versions that I'm working with, I tested that they worked at some point. If I later wanted to upgrade these things, I could upgrade to newer versions, but I know that this version should work. So I'm just going to type in make install. Here we go. Go ahead and run this make install. It looks like it's working. Maybe I'll make this a little bit smaller. Maybe even a little bit smaller. Let's see. Whoa, there's a lot of space down here. There we go. That's better. So now that I've got, no space left on device. Well, that might be because I have too many. If I say Docker images ls, maybe, I wonder what I have on this thing. df-h show, yeah, there's a lot of stuff on this machine that might be difficult to find, which is kind of a bummer. So I think it would be Docker image ls. Yeah, here we go. This is the problem, is that I have a bunch of Docker images on here. And so this can happen when you're dealing with things. So what I can do is say Docker image purge or prune. I think I can say prune, which will remove an image for me. So Docker image prune, and then you put in, I believe, all images without at least container. Sure, let's try that. That looks dangerous. And because I'm on a machine, I just don't care what happens to it. This is like I'm renting a Corvette or something, and it's got great insurance. Ah, that's a good one. That's actually a very good one. You're right. I could just go to into EC2, right? And I could just resize it. Ah, okay. I don't know if I've used that before. That sounds like, so let me just see if I fix this or not. Well, this looked like it did fix it enough. So for now, that is a good, I will use that at some point. That is a good suggestion. For now, I just by being, running this Docker prune, I can just get rid of all of them. Okay, so I'm temporarily got me through the mess here. So again, I'll do make install to get me back to install the packages. Okay, great. Now they work. It's actually good when problems happen because it shows you the real world. It's like a stress test. Okay, so next step here, we got this running. Now we know that there's a file here called app. I didn't really talk about that one yet. Let's go to app. And if we go to this app here, this is something that you could probably copy or just tweak a little bit, but this is from Flask, import Flask, request, JSONify. This is all boilerplate code. You could kind of cut and paste this probably in every Flask project. And then also this is somewhat boilerplate code, like import pandas, that gives us the data frame. Import joblib, that's what lets us import the serialized model or the pickled model. And then the scalar, again, all machine learning models for the most part, there's a few that don't, but most machine learning models, you have to scale it. So whenever you put something into it. So I wrote a function here that is called scale, and guess what it does? It scales the data. So that solves that problem. I also added some logging because any production application, it's grossly irresponsible to not add logging. The equivalent would be, I was just talking to some people in China that I work with this morning actually, and they said to me, it's very unfortunate that you don't have testing in your country. And I was like, you're right, it's very unfortunate. It's the same thing that happens when you're building an application. It's equivalent to testing, right? Like you want instrumentation logging so that you see what's happening inside of your application. Why would you not want that? It's again very similar to the COVID-19 thing, where why would you not want to know who has it, who doesn't? This seems like common sense. Also, building applications, why would you not want to know what it does, what goes into it? That's what logging does, is it's really the instrumentation. So the only other part here is this app part, and I put a decorator on top, and I say /predict, and I put in a post method, and the post method allows you to accept a body. So it means that when you make a request to it, you're going to pass in a JSON based payload. In fact, I put exactly what the payload would look like, just like this. So you can see what the payload is. And then I also put in there what the prediction would look like. So that's all you need to do to make a machine learning application that runs in a website somewhere. So first I accept the JSON payload from the Flask request. And the way you do that is you say request.json. I log what it is so that I can tell what's happening. I then put the payload into pandas. I log that I've got it. I scale it, because again, remember, you have to scale things for machine learning models for the most part. Then I do a prediction. And then finally, once I've done the prediction, I just return back the prediction. So could be literally like Zillow, right? This could be, you could write a Zillow API that has all housing prices, and you have a model, and they pass in a JSON payload, and the JSON payload is, here's my zip code, and here's the 3-bedroom house, and then it comes back and it gives you a prediction, right? So this concept is pretty straightforward and actually very useful. And then here's the part that is not even that tricky, but this is where we pull in the Boston housing prediction joblib file, right? That's the serialized model that I trained somewhere else. And then I go here and I say run. And that says run on port 0000, port 80, run my application. Now, one gotcha here is that if I wanted to run this and expose it externally, I would have to open up the security ports for Cloud9. But for this, I'm just going to do everything from the command line, so I can just run it locally. So I'm going to go here and then say Python app.py like this, and it should. That's weird. Why would it? Did I not put pandas into the requirements? That's very strange. Let me do it again. Pandas is already installed. Oh, you know what it is? It's Python 3 is the problem. There you go. That should, because there's, okay, at least this is better. And then for port 80, maybe what I'll do instead here is, because port 80 is a privileged port, so it means that you have to use the sudo command. So I'm just going to change it to port 8080 like that. And then I'm going to run Python 3 and that should work. Okay, so it's running locally in my shell. Now, to make it easier for myself to debug this and to test it, one of the things that I did was, if I go back into this directory here, there inside, and I go to demos and I go into Flask scikit-learn, is I created a bash script that does the curl command for me, just because I don't like typing in these commands. So I think it's right here, make prediction. And you can see what it does is I just say, here's my port, port 8000. In fact, I should change this to be port 8080 like that. And I make a curl command and I just pass in the body and then it will make a request to that application. So if I run this, so I'll go ahead and save it and I run this, there we go. This is make prediction and I get a prediction. And if I tweak it, I will get, different prediction values. And if I go back to my Flask app, you can see here that this is where all the logging can be really handy, right? It's because I can see this log level and things are working. So that's phase one, which does anything work? Can I? And so I have this is effectively, that's it. You have a production machine learning system that's pretty much ready to go. Now there's a bunch of different options. One, maybe you don't want to do Docker and you don't want to use Kubernetes. Maybe you're good to go. You just do, on AWS in particular, they have something called Elastic Beanstalk, and in fact, I haven't used it in a long time, but you could potentially just do this: create a new environment, say web server environment, call this Flask, and then sure, leave it the same. And then for platform, choose Python. For platform branch, Python 3.7. And then upload your source code or go to public. I think I could do this. I could pick public S3 file. No, I guess I would anyway, I could upload some zip file, put it inside of here, and then anyway, it could manage, it can do Flask. So Elastic Beanstalk can just that could do Flask on AWS. So that, I don't necessarily need to do Docker or Kubernetes at all. So that's one option. A second one is I could also just slightly tweak this, and I could do it with App Engine, which we went through earlier. And there's some advantages to App Engine because it's a platform as a service. And the only thing we would need to change here would be that this file, I believe, would need to live inside of the Google Cloud Storage. So that would be another option. Yet another option. I mean, I think the Beanstalk is probably an interesting one for many people. Another option would be you could just go to EC2. You could spin up an EC2 instance, install Flask, which is pretty straightforward to do, run it, put it behind Elastic Load Balancer, and you also have a machine learning application that runs. So that's option. That would be third option, I guess. Two options on AWS, one on Google Cloud. And then there's also the container story. So let me just show you the container story a little bit if we go back here. So I'm going to stop this and then show you how to run it in a container. So if we go to Docker file here, I have a script where I make it a little bit easier, which is I say Docker build. So I'll just run each of these one by one. So I'll say Docker build, and I call it Flask scikit-learn. There we go. It goes through, it builds this container locally, and then the next step would be Docker image ls, which would be the next step. All right. And then we say Docker image ls, so I can see that this is there. And so another question someone had is, when we call the payload, does it run job lib each time? So when you call the payload for this application, this only runs on startup. When you put something inside of the name method, basically this is a loop. This is like a run loop. And so this only runs the first time you start up the application. So the way you could test this out is you could do this. Let's just say this, just say started, and then you could go like this. And this is a good way to test something, right? Right. That way you know how many times it was called. So what we can do is we can just start this again. So Python 3, and we should see a message, right? There we go. Look, started, right? We can see that that was run right before that line of code. And then if I close it, it's going to say ended. There you go, ended. Right, so that is a good way to test things out, but this only loads once the first time, and then this is an event loop, and the event loop is just constantly running, listening for requests. Good question, though. So now that I've built the image, I believe the next step here would be to run it, and the only other thing we would need to do to run it in Docker would be to make sure that everything matches up. So I think I need to make this port. Let's see what I've changed the app to. It's going to be running on port 8080. So why don't I just make it simple and say I'm going to have port 8080 talk to port 8080, right? So basically pipe through port 8080 to this Docker command. I'll save it, and I'll go like this, Docker run. And then now this thing's running on port 8080. And what I can do is do the same thing that I did before, make the prediction, and it should work, and it does, right? Because now, but the difference here is that this is now running in a container. So why would you want to do this, and what would be the point of doing this and everything? One of the reasons why Docker is kind of interesting is that you can publish this to somebody else, and then they can test out your code. So what I'm going to do is I'm going to actually push this to Amazon Container Registry. So I'm going to go back to this. Uh, yes, everything's being recorded. And we're going to go to the ECR here. And this is a repository that will create. And I'm going to go ahead and create a repository called demo April 18th, like this. And this is basically like a kind of like a Git repo, but just for containers that I'm going to push, that I'm going to let you push, that I'm going to push containers into so that I can do things on AWS with it. So how do I use this? Well, I'm going to copy this. And then I'm going to go to this, and I'm going to log in, and it says something I need to copy this. I think I need to just use this copy command like that. So basically this is going to authenticate to, that's weird. I've never seen this before, that it's saying that. Maybe I can do it in a shell, another shell. Let's see. So authenticate, cannot perform an interactive login. I have not received this error before, um, which is kind of irritating. Maybe I need to open up a new shell and clear things out or something. Let's try this. Yeah, I think that typically maybe the username, that's weird. That typically you should be able to copy to retrieve an authentication token. Yeah, this is weird. It's like something's broken. Typically, I've been able to copy this, and I haven't had an issue. But let me copy one more time here and see. I don't know why it's acting. Usually, I just can cut and paste exactly what's in there, and it works. Psh, weird. That is really weird. Yeah, because username AWS. Yeah, because it should. Let me try one more thing here. So I'm going to just do part of it. I'm just going to do this part of it, which is ACR. Not that big of a deal. I have a workaround, which is um, hmm, what I can show. It doesn't matter which container registry we use. Another one that I can use is I can just use Docker Hub. So we covered this earlier, but in Docker Hub, the idea here as well is just to log into it and then push something to it. So I'll go ahead and sign into this. Probably have a login saved here. So if I want to create a repo, I'll create one called today, like demo April 18, and make it public. And then what I will do, you can push a new image. Okay, we'll create this. Great. And then push a new image to this. So all I need to do then is basically go back here, go to this repo, and push this. Okay, it says an image doesn't exist locally. So we want to find out what the image was that we created, which I think is called Docker Flask sklearn. So I'm going to say Docker image ls, and I have this Flask sklearn Docker push, and we'll try this. Okay, so it says it's denied because I have to authenticate to it. So in order to authenticate to Docker Hub, I need to, that's public view. I need to actually, I forget how you auth to Docker Hub again. It's, what is the command? It's, let's see, Docker Hub auth. Actually, I might have it in here. Let me look here. So I have demos, run Docker, upload Docker. This is what I'm missing. So I need to do this. Docker login. That's what I need to do. There we go. So I'm going to go back to this and just say Docker login. And okay, I must have logged in at some point. And then I push this. That's weird. Why is it having problems? So I have a double login problem with Docker. Yeah, maybe this is authenticating with it. Your passwords are stored unencrypted. Login successful. Docker push. Requested access. Oh, you know why? Because I'm messing up because I'm pushing. I need to push to the right location. I think that's what I'm messing up. So if I go back here, this is what I want to push to. I want to push to this, push a new tag to this repository. Let's try this. This push refers to the image does not. So I need to create that image. So let's build that. So I'm going to say tag, Docker tag, and we'll call this gift April 18th. See if that works. Docker build. Docker. Let's just copy this whole thing and I'll change it out. So here we go. Okay, build this image, but we need to call it this name, which would be here. And we'll call it tag would be why am I messing this up here? What am I doing wrong here? Let me double check here. So Docker build this, Docker path. This might be what I'm missing. Okay, I'm just going to tweak this. I already had a script that makes this easier. I'm just making things more complex than they should be. So this demo 18th, I'm just going to tweak this a little bit. This script I already had, which is this. So I'm going to say this assumes that this is done. So we're going to tweak this, and I'm going to build one called demo 18th. There we go, Docker path. So I'm just going to run this and see if this works, which is upload Docker. And we'll run this. And once that's done, so first it builds it, then it pushes it to Docker Hub, then I can open up a second environment and pull this in and run it. And that's basically the point of um, of Docker, right? Is that you can transport a whole application and run it somewhere else, even a complex application like a machine learning application. So let's see if this thing works. And I believe if I build this, that it should build it with port 8080 as well. Yeah, the Docker hub would be for public, like if you want to give this to somebody so they can in the public use your application, and then ECR would be Amazon's container registry would be if you're running something on the Amazon um, ecosystem, it's going to be better to put it into ECR so that you may have proprietary source code or you may have some other thing that you don't want people to have access to, and that's why you would put it into ECR. So I think on AWS, most likely you'd want to put it into their container registry. I don't know. I've never had a problem with this before. I don't know why it's freaking out. But now that I pushed this here, you can see that this now it contains one tag. There we go, latest, see all. And so I could, for here, grab this, and now I'm going to go to a brand new Cloud9 environment. So I'm going to go to Cloud9 here, and then just spin up a totally different environment to test this out. So go here, and we'll make a new one. Demo April 17th. Just say next step. Keep it all defaults. This should take just a second. And what's kind of cool about this is that you saw like a little bit of work to get everything running, get Flask running, get it all, the instrumentation, the logging, all that. But then what's really cool is that I can just take that whole app and run it somewhere else or give it to another person, and all they need to do is run that command Docker run. So again, we'll test this out in a second. This will just take us 30 seconds to test this out. Yeah, I'm not sure why the ECR, who knows, maybe their website has a bug, but typically when I've used ECR before, I literally just copy. They have links where you can copy and it just authenticates. You don't have to do anything. It just remembers how to log in. So there's something weird going on, but it's really not that big of a deal for what we're doing. Just the main concept is that you can take an app, build it, that's a scikit-learn app, and then run it somewhere else. So we have, okay, brand new environment, right? There's nothing on here, right? So which one? Oh, maybe, yeah. AWS. Oh, that could be it. Ooh, yeah, maybe you're right. Is that an older version? No, it's on 1.17. Oh, yeah. Okay. Well, there you go. That's a good one. So I guess I could do what? Sudo apt-get. This is an old machine. Really? They don't have apt-get on this? No, yeah, because it's Red Hat. That's right. It's sent to us. So sudo yum update, and then we can see a bunch of tons of updates, right? That, in fact, probably that's a good one. I like you helped me debug that. So here um, we'll say yes, and now if I type in AWS, it should give us the new client. And let's see if this works. So we'll have two different things we can demo. So let's see. Okay. I believe that this should work. That to upgrade the AWS client. I'd be very surprised if this doesn't work. I've actually never upgraded the AWS client. I just create new environments. Oh, didn't upgrade it. So I wonder how you do upgrade AWS client on Cloud9. So upgrade AWS on Cloud9. What do they say? They say, change the settings, update environment. Really? That's weird. That seems so strange to have to do that. It seems like a lot of work, but if I have to do it, I have to do it. But I thought you could just do this. I thought you could just say yum. Did I not do this? Let's try this. Let's go back to this and AWS CLI. What did I run? I said yum. Yeah, yum update dash y, and then package was already installed. I don't know. There's something we can get. Maybe we'll try it on the new environment. Here we go. Let's try this. But first, let me finish this part. So AWS version 1.18. So this one's slightly newer. But the main thing I want to show is there's nothing installed. There's no tricks, right? I have nothing on this machine. But what I can do is I can go back to this Docker environment, copy it, go here, just run that command, right? And it's going to pull the image down locally. And then all I need to do to test it out is basically run that curl command and also tell Docker container to run. So let's while that's running, I'm going to go back here and I'm going to find the command that we're going to use, which would be um, something like this. I'll have to tweak it a little bit, but it'll look something like this. So I'm going to go here and I'm going to make a new file called docker run.sh, and I'll edit it, paste it in here, and we can see this one, newer image. So I just need to do, so it's already been downloaded. I think I can just do this. I think I can just say docker run -p 8080 colon 8080, and then just do this and put that in there. And does it run? Okay, so it runs and it's running on port 8080. There we go. And then the next step would be that I would want to test it. So do make prediction like this, and I could just do the same thing. I could just copy this into this environment. And again, the only reason I'm doing this is for laziness, is that I don't want to have to type this curl command in. It's just a lot of work to type the curl command. So I'm going to say new file, save as, and this will be predicts.sh. Throw this in there. There we go. And we double check. Yep, that's port 8080. So it's just going to do a curl command to test our Docker app. And I can open up a new shell here. Actually, I didn't know you could do that. I'm going to open one here. I'm going to say new terminal. And then I can just do this. I can just say chmod plus x predicts, and then run predict. There you go. So we know it works. So to me, this is the power of Docker, is that like I've got all this stuff running. I've got the machine learning model. I worked with the data scientists, package it all up, push it somewhere else. I then bring it on a brand new environment, and now I got machine learning running at scale. So this is pretty close to where potentially you could end things. Again, I mentioned that that the other option is the elastic beanstalk could be an interesting one, and then you could start doing load testing. You could start doing all kinds of other stuff. I've only played a little bit around with EKS and Fargate, but that could be the other deployment target, would be something like EKS or Fargate. So I guess, yeah, maybe a good stopping point here would be any questions about this is pretty close to end-to-end how to deploy machine learning at scale in production. So any questions about this? Okay. Hmm. Yeah, so this with continuous delivery, the next step would be if we went on AWS, for example, if we let me go back to this thing for a second, that if you go to this file, which is the make file, there is this thing called Lint, and it's a tool that is a little bit tricky for some reason to install on Cloud9. I've gotten it to work before, but it's just like a little bit tricky to get it to install. But basically, it's kind of like PyLint. You can lint the Docker file, so you can basically make sure that you're not making mistakes and things like that. but that could be part of another thing you test maybe with Circle CI. But then the delivery part would be that you're also packaging this whole application up and then putting it somewhere so that it runs in a particular environment. And the way that you could do that would be to, again, if we go back to our AWS console, they have something called, which is similar to Circle CI, they have something called code pipeline. And it's part of, I guess they have code build, code deploy, code pipeline. If we go to code pipeline here, what you could do is you could say create a pipeline, and then inside of this pipeline, we'll just call this continuous delivery. And then we go to next. Where's my source code live? We'll say it's GitHub. I'm going to connect to GitHub. There we go. I'm going to pick the, where is it? This repo, container revolution. Here we go. Here's my container revolution. I could pick which branch. So maybe each branch you could have, the master branch would be for production, or actually typically master branch would be maybe development environment, and then you would have a separate branch that's production. And if you merge stuff into the production branch, it would put the code right into your production website. Now, by default though, we'll leave it master. And then for the build provider, you could either pick code build, which is also part of AWS, or you could have your own Jenkins server that does a whole bunch of stuff. And the Jenkins server could be, doing a bunch of separate steps. I'm going to pick code build, and then we're going to create a project. So let's let this thing kind of sit up here. Hopefully you can, this is, yeah. So yeah, what you could, this is kind of what I was getting at is, in fact, let me actually see if I can open this up here, is you can actually build the Docker containers. Here it is inside of code build itself. So let's again call this demo April 17. And if we go through here, you could either, now when you build it, it itself has containers, which makes things a little bit complicated, but let's just for now say operating system, Linux, standard, and then image, we'll just pick this one, always use the latest image. And then this one, this is where enable this flag if you want to build a Docker image. So you could also have code build itself build the image for you. So if you're changing the Docker container, every time you make the change to your project, it could make updates to it and repackage the container for you. And inside of it, you could put a configuration file that would have all of your information, like how to lint it, how to build it, things like that. So if I went through and I did this, and I created this, then it would hook into this code delivery pipeline. So basically, in a nutshell, if I just go, I think this thing was created, create build project, demo. There is no reference to the window opener. Well, it created this. So I think I freaked it out because I copied the window so I could show it to you. But basically, we could go back here to this. I think it should be here. Yeah. And then like basically it's created a pipeline. So this is similar to what we've already seen with Circle CI. The difference is that you can do it all in Amazon, and not only that, it will actually hook into Amazon's deployment system. You can do the same thing with Circle CI as well. They all work the same. But here for the deployed provider, this would be the continuous delivery aspect of it, which is, okay, now where do I want to put this? Do I want to use um, OpsWorks which is a chef based, it's like some Ruby code that installs it. Do I want to use Elastic Beanstalk? So Elastic Beanstalk was the one I mentioned before, that you can deploy a Flask app with a Beanstalk. You also could do ECS, which is Elastic Container Service, and you could deploy your application there. So let's just pick that for a second. Then it's going to ask you what kind of cluster. So you have to have a container cluster running, and then basically once you hook this up, you click the button and it'll auto deploy. So this would be a little bit tricky to set up right now, because I would have to set up a cluster for things to run to. But yes, this would be basically how you would do that on AWS. Does that answer your question? You don't have to. I mean, I think you could stop. You could really stop probably like right here, like what I just demoed to you, which is build a container, kind of test it out locally, put it put it somewhere. I do think that if you were able to deploy this, so maybe just you could stick with the linting and do that part of it. That's continuous integration. It would not hurt though to demo that you know how to do continuous delivery. I think it would look pretty good in terms of companies that were interested in hiring you. So if you do have the opportunity to do this, it wouldn't hurt. And again, I think if you're using AWS, this one would potentially be one way to do it. With the Google Cloud Platform, I mentioned that earlier, that App Engine, we did that earlier, right? Is we built a continuous delivery pipeline, which is your code is inside of GitHub. Every time you make a change, it goes through and it tests it, and then it deploys that code to an environment. That's another option. You could use Google App Engine, or you also could use this thing plus, let's say, Elastic Beanstalk. I think the most powerful demo is when you go completely end to end, and you get it so that every time you make a change to a project, that it would lint it, test it, build it, and that you also could build the Docker container and you could deploy your application. That would be the dream scenario that I think everyone would probably have the best, um, the most powerful demo. But even if you just get to the part that I showed right here, I think that's still a pretty good demo. Okay, so another question someone has is, can you elaborate on the final project, verify the scale up performance via load test, loader IO, or similar test framework, and verify two or more endpoints? Yeah, so the idea here would be that, and again, you could, if you wanted to, you could separate this into pieces, is that this would be a good way for you to get experience with doing load testing. And I think I did go over locus at one point. Is that correct? Did I not go over locus? I thought I did go over locus at one point in class. But the idea here is that you have an external system that can verify the performance of your application. And if it's running in an environment, then that's how you would verify its performance. So let's say that, I mean, one thing you could do as an experiment would be, if we went to, let's take this Docker build environment, for example, and let's actually just make it run on port. Let me change the port here. Let me look. Let's actually just run this. So I'm gonna show you how you could do a very simple test of this. We could say Python 3. Does this work? Okay, this works. So now what I can do is I can go back to my my environment, EC2 environment, and then I could go to running instances. I could find Docker build. I could find the security group, which is this one. I could edit the inbound rules. And oh, cool, I must have done this before earlier. We can see that I can talk to it externally from port 8080. So that's one thing that you would have to do is if you wanted to test it the way I'm about to show you to test it, you open up port 8080. If I go back to the instance again, I can find its IP address. So we know that this Docker build file has got this public IP address. So I could, from this machine, the demo machine, right, there's a totally different machine. I could actually curl it. Let's just curl this. Oh no, but I need to curl port 8080. There we go. So we know it actually is working, so, right? So I'm actually able to actually test it locally or test it from one Cloud9 instance to another. So then, look, you can see, look, that this was called. In fact, if I go back here, I can just say like watch. The watch command just runs a command over and over again every 5 seconds. Now look, if I go back to this, look, see, this would be like the crudest possible load test, and this is good enough. If you want to stop here, this is okay. But that's like the simplest possible. Now, if you want to get a little bit fancier, which again, it depends on how sophisticated you want your demo to be, then what you would do is you would install Locus. And I believe I did show this earlier, but let me do it again. Let's see here, Locus. Locus Python. I thought I even had this in a repo somewhere. I write so much code now that I don't even remember what I wrote anymore. It's either old age or it's or or I'm doing too much stuff. So here we go. This is what I was looking for. So I have this repo, and I'll put this into chat here. So what I'm going to do is I'm just going to copy this. This looks good enough, right? So I'm just going to say copy this, and we'll call this locus file. I'm going to go to this thing here, locust file.py, and then put this in there like that. And then I think I can just say pip install locus. Is that what I do? Let's just double check here. What do I do in this project? Make file requirements. Yeah, I think I just do that. And I think I might have had some more, but I can figure this out real quick. I think I have the instructions in here, which are cloud computing for data. Let's just look at this. And can't even find my own website. Here we go. This. And then if I go to this section, I think I have locus somewhere here. Locus. Here we go. Create a load test. So I'll also show you this one. And then what I do is I think I just pip install this locus. Yeah, so I'm just going to do that. I'm just going to guess here that I pip install this. Sure, that should work. And I think I have a whole video on this as well that's in there. But let's do it again just so you can see. And okay, that looks like it works. While that's working, let me just see Python locus run. I think I just need to give it a file. So I think I just say locus, yeah, this. Okay, So here, so this will take just a second to install this. And so in this case, for now, this is okay because the Flask app has a route on the main route. Probably better would be to put in the JSON payload and run the JSON payload over and over again. But for now, this is fine just for a preliminary test. So this should take just a second. It's amazing. This G event library is takes a long time. I guess I could see the computer if I open up terminal. If you're ever curious why something's taking a long time, you can run top. Oh, it looks like it stopped. Uh-oh. That's weird. So why does it say, it says permission denied 0MQ. That's interesting. Permission denied. Weird. So, you know what it is? I need to do this in a virtual environment. I'm being sloppy. So I'm going to create a virtual environment, and we'll call this load test tilde load test, because whenever you use the system Python, all kinds of weird things happen. So I'll source this called load test. Now, if I do pip install locus, it should be way better. Okay, and then I can say locus my, in this case, this will be locus file, but we need to double check this locus file here. How is it going to know who to talk to? That's going to be the part that I need to double check real quick, is how does it know who to talk to? Okay, here we go. We want to say, we want to tell it the remote location. So we want to say locus file slave. If you want to run on a distributed machine, I think we want to tell it where to go to, which machine to actually talk to. Locus master. There's got to be a simple writing locus file. Start, open up, start locus. Oh, okay, no, yeah, you run this, if I'm remembering correctly. So I just run this. It will open up something on port 8089. So I need to go back here to EC2, and I need to open up port 8089. So this would be this one. Again, go to security group, open up inbound rules to port 8089. So we'll edit one. Wow, they changed everything. So all traffic, what? TCP custom, custom TCP, there you go. And we want to see 8089 like that. And sure, we'll save it. So now that that's running, I should be able to go to this machine here and find its IP address, which is this one, this, go to this, put in 8089. There you go. So now I can say I want to spawn 5 users. Sure, 4 users per second. And then the host would be this host. So it would be, um, which is, I guess I was running this. It was in this, wait, wasn't I testing this earlier? I can just go history. I have the host of this. So it's going to be this. That's my host. Okay, so let's go to this. Let's put in this host. Let's swarm it. And we can, while this is swarming, we can look to this machine. Whoa, what is this doing? No connection adapters were working. That's interesting. Demo. Let's double check here. Maybe I'm doing, maybe I'm getting confused because I'm running. Okay, so let me just double check that I'm talking to the right machine. So over here, Docker build is the one that's running this web app, I believe, or is it not? Yeah, so this is the web app is on Docker build. So I'm going to double check here, go to Docker build, and this is the IP address. So maybe that's what I'm messing up. And then if I look at the ports that are open, here, this should be port 8080, inbound rules. Okay, so let's go back to locus and do a new test. And was that the right IP address? Yeah, that does look correct. But and then if I say swarm, it in theory would, for some reason this thing's acting weird. I'm not sure why that's acting weird. Port 8089. It it may be that I need to open up another port between this thing and Docker build. Anyway, the gist of this is that this is close. This is pretty close to what you could do as well. You don't necessarily, you could separate the problem into different pieces. If you don't want to go full continuous deployment, do some iteration of this, do a little bit of a load test, or do a load test where you could even run the load test on the same machine. I think that was this demo that I showed you earlier, was that I had in the link that I gave you earlier, this link, this video, that I actually just do the load test on its own machine. So again, it's totally up to you how complex you want this to be. You could just break this into pieces and show little pieces of it and theoretically show it. I think the big takeaway is that if you the more realistic you show this and the more end to end you make everything, I think it shows more mastery, and it shows how you would be a plug and play into a company. I personally, if I was, I don't hire people anymore, but if I was looking to hire a software engineer and I wanted, and we know that machine learning engineer is one of the hottest jobs right now, and I saw someone do basically all the things that I just showed you in this video, and put it all together, and then you just sequentially built the whole thing, and that's exactly what I was looking for somebody to do in my company. That's a pretty compelling reason to bring you in for an interview or hire you immediately, right? Because you're doing exactly what what I would want someone to do, is deploy machine learning, test it, log it. So hopefully that's probably a good stopping point. I'll just stop recording